Hey everyone, so this video is just going over a homework assignment where we were solving for x in an exponent without using log. Instead, we were using the one-to-one property and solving by hand algebraically. Our answers were all rational numbers. That means that they can be written as a ratio, so they were either integers or fractions. Let's start over here with this first example. The directions will say the same thing, solve for x using the one-to-one property as demonstrated by the lesson. So let's dive right in. Towards the end of this sheet, there are a few questions about factoring because that did pop up in some examples where we were solving our exponential equations, but we will cross that bridge when we get to it. 2 to the x equals 8. We are looking for a swopportunity, which is an opportunity to swap out my bases for smaller numbers to a power. We're hoping to make sure that both bases are identical. That will allow us to use the one-to-one property. 2 and 8 have a common base of 2. 2 to the x will stay 2 to the x. 8, however, is 2 to what power? 3. Now, if 2 to the x equals 2 to the third, that means x must equal 3. That was the one-to-one property in action. Next, we have another question with 2's in it. 2 to the 5x plus 1 can just stay the way it is. 32. Let's find our swopportunity. 32 is really 2 to what power? 32 is 2 to the fifth. Then we set our exponents equal to each other. That means 5x plus 1 must equal 5. And now all we do is solve algebraically. 5x equals 4. Divide by 5. And our final answer, x equals 4/5. Next, what base can we get written on each side? We only have one term. We don't have to worry about that part of it, but we need to get these down, ideally to a prime number to a power. 3 is already done. 3 to the 2x. What can we do about that 27? Twenty-seven is 3 to the third power. If 3 to the 2x equals 3 to the third, that means 2x must equal 3, and then we can divide both sides by 2. X equals 3 over 2. What's 3 over 2 as a decimal? That's 1.5. But fractions are our friend. We can leave it that way. Next up, we have 3, which is already prime, so we are going to leave that the way it is. The negative 2x plus 2 equals 81. 81 is 3 to what power? 3 to the fourth. You really want to be very good at knowing a whole variety of numbers raised to a power by heart. It makes this a lot easier. Now we have one common base raised to a power on each side. The 3's match up, so the exponents must match up. Negative 2x plus 2 is equal to 4. Subtract 2 from each side. Negative 2x equals 2. Divide each side by negative 2. X is negative 1. Our next example, we have a 4 and a 64. Now, you can do this problem by using 4 to rewrite the 64. And we can make it 4 to the third. But I always try to go down to the smallest number, so let's look at it that way. 4 is the same as 2 to the second. 2 to the second is being raised to the 3x because 4 is 2 to the second. 64 is 2 to what power? The sixth. Property of exponents tells us that we multiply these powers. So 6x must equal 6. Divide each side by 6, and we'll get that x is equal to 1. Let's do it with 2 again. 2 to the 3x equals 2 to the second to the x plus 1. common area of error, we're going to have to multiply our powers, but make sure you distribute that 2 to both the x and the 1. This power of 3x must equal this power of 2x plus 2. Subtract 2x from each side. 1x, or x, equals 2. What number should we use for our swappertunity for this example? We would use 5. 5 is already prime. 5 to the 3x is really broken down pretty far. 125. 5 to the 0 power is 1. 5 to the first is 5. 5 to the second is 25. And 5 to the third brings us to 125. If we have 1 over 125, that's really 5 to the negative third power, because negative exponents move an expression to a negative power to the denominator or create a reciprocal relationship. 3x equals negative 3. Divide both sides by 3, and we'll get x equals negative 1. Looks like we have another relationship using the base of 3. We're going to swap 27 for 3 to the third power. 3 to the x plus 1 equals 3 to the third to the 2x. 3 to the third to the 2x becomes 3 to the 6x. One-to-one property, we're going to ignore the base of 3. That means x plus 2 equals 6x. Subtract an x from each side as we try to get x isolated. Divide by 5. X equals 2/5. Now, just to talk for a second about this one-to-one property. If you remember when we spoke about exponential functions back a while ago, an exponential function passes the vertical line test. It looks something like this right over here. That meant it was a function, but it also passed the horizontal line test. That meant that its inverse would also be a function, the inverse being log. Both of these functions pass the vertical and horizontal line test. We said that these were one-to-one functions. That meant 1x for 1y for 1x, inputs and outputs. No input or output had more than one corresponding value to go with it. This is why we can set the exponents equal to each other. In order for 3 to this power and 3 to that power to be equal, there must only be one solution. The only way that that can happen is under one condition. It's not like a parabola where a quadratic could equal a line in more than one place. That is not one-to-one. This is a one-to-one relationship. These are one-to-one functions. That's why we're allowed to use the property which is called the one-to-one property. For these last 4 examples, we have some questions that involve factoring expressions and solving equations. While similar, they are different. We always pay attention to the directions and the setup of the problems. Factor the following expression, no equal sign, no solving. Show all work. If you were to use the AC method and factoring, that would require more written work. What multiplies to give me 2m squared? My first and first have to give me that expression. Since 2 is a prime number, I know it's 2 and 1, and then I'm also going to have m and m because my middle term is just m to the first. Now, my last 2 terms need to multiply to give me 15. I'm really left with picking 1 and 15, or 15 and 1, or 3 and 5, or 5 and 3. But I need my outer and inner to give me negative 11. If this sign is positive and this sign is negative, I know they're both negative. Because last times last has to be positive. That means they're both the same. And outer and inner is negative 11, so they're both going to be negative if they're both the same. If I put a 3 here, I'll get a negative 6m for my outer. 3 times what is 15? 5. 5 and 6 makes 11, as long as they're both negative. I'm done and factored. To use the AC method, you multiply A and C, which is 2 and 15. That gives 30. Now I'm going to find a pair of factors that multiplies to give me 30, but I also want this pair of factors to add or subtract to give me negative 11. I would use negative 5 and negative 6. We use these two numbers to break apart my middle term and build up a quad that will factor by grouping. 2m squared minus 5m minus 6m plus 15. 2m minus 5 is my new greatest common factor. I'm going to factor that out front, 2m minus 5. If I bring that out front, what's left inside? M minus 3. If you need to do it the long way, definitely do it the long way. If you can jump right to the answer, great, but make sure you know how to do it because factoring is one of those things that just really never goes away. Next, we have this special example, and this could also be looked at in two different ways. Well, really three. You could do AC method, no thanks. We're really just going to remember that if you have no middle term and you have the difference of two squares, you can factor with conjugates. What's the square root of 9x squared? It's 3x. And what's the square root of 36? 6. And conjugates are the same expression, but with different signs in the middle. Just like conjugating verbs, you keep the beginning and you change the ending. Now, while this is factored, it really isn't completely factored. I have a greatest common factor of 3. And I have another greatest common factor of 3. That makes my final answer 9 times x plus 2 and x minus 2. I could have factored out that 9 first. In class, I've always told you, always look for a greatest common factor first. 9 and x squared minus 4 is left inside. If I divide each of these pieces by 9, because I'm multiplying out front by 9, gotta keep the balance. Now, x squared minus 4 is also a difference of two squares. The square root of x squared is x, the square root of 4 is 2, and I'm going to use conjugates. Order doesn't really matter with multiplication because of the commutative property, so we're good in either case. Solve the following equations, show all work. Here we have a polynomial equation. These may come up when we're using the one-to-one property. What if I had an example where this was something like 4 raised to the x squared plus 18 equals 4 to the 9x? Well, if I had something like that, and those were my exponents, one-to-one property would want me to set the exponents equal to each other and solve. So here we are, practicing setting two expressions equal to each other and solving. When we solve a quadratic or any polynomial equation, you want to make sure you get the polynomial equation equal to 0, and you also put it in standard form. Standard form is also known as descending exponential order. We have all of our like terms combined, and we're in order from biggest exponent to smallest. Now we're going to factor this quadratic. I'm not going to do this out the long way, but if you did, you would use 6 and 3. Because my leading coefficient, a in the ax squared, is 1, it is much easier to factor this using the shortcut than it is for something where the a is equal to something, say, 2. 6 and 3 are the two numbers I want to use because they multiply to give me 18, and I can make them add or subtract to give me negative 9. If this is positive, that means both of these signs are the same, and they both are whatever this sign is, so they're both negative. Now I finish solving with the zero product property. Again, these directions said factor, and it was an expression. Here it says solve, and it's an equation. These are different circumstances. With zero product property, we're going to set each of the factors equal to 0. If x minus 6 is 0, x equals 6. And if x minus 3 is 0, then x is 3. Here's our last example. It's more similar to this one. 2x squared minus x minus 3 is 0. If we factor and use a C method, you should get the same answer I'm about to get right here. Factored form should give you 2x minus 3 and x plus 1. If you need practice with factoring, you should definitely go and look up some of the older factoring videos so that you really know what you're doing. Add 3 to both sides after you start your zero product property. Now I'm going to divide by 2. That gives me x equals 3 over 2. X plus 1 will also set equal to 0. Subtract 1 from both sides, and x equals -1. Which number is bigger, 3 over 2 or -1? A positive number is definitely bigger than a negative number, so 3 over 2 is definitely the bigger number. -1 is definitely smaller. So if you needed to list your answers in order from smallest to largest, they would go in this order. You can list them with x equals, comma between them, or we can use set notation, or if the directions say just to list them and separate with a comma, you could do that, just don't use parentheses or people might think it's an interval or an ordered pair. I hope this helped you out. I hope you're comfortable solving for a variable and an exponent without log when you're able to use the one-to-one property and swappertunities. For factoring lessons, you could see the videos that I will be linking to this video.